In this video, we will work on this problem from Advanced 2020 Paper 2. So first step, let us read the problem and completely visualize the problem, what is happening overall, identify the key points. So if you read the problem, we will see a person is skating up a ramp with a starting speed v0, right? And then the person reaches the highest point h from the ground, and it also says that there is no energy loss. That is a hint that we have to use energy conservation in this problem. And then it also says the force required for this turn at the highest point is provided by only weight. So at this point y, the centripetal force required for the turn that is only provided by the weight. Now the goal is to check each option if that is correct. But before we jump into solving, we should read the options and see if there is a relation among those. So option A and B, they are about relationship between V0 and H. And they are contradictory. So only one of them can be correct. Then options C and D, they are about centripetal force at points X and Z. And they are also contradictory, so only one of them can be correct. Now let us look at options A and B. So we have to use energy conservation because the question says the energy loss is negligible. So at starting you have a speed v0 going up the ramp, and the person reaches the highest point y, and now its speed is v1. It cannot be 0 because you are making a turn, right? So v1 is less than v0 certainly, because the person is losing up the energy as you are going against the gravity. So we will use energy conservation between start point height 0 and highest point y height h. So initially kinetic energy is half mv0 square, right? And we say that at the start point we can set height equal to 0, and at the highest point height is h. At the highest point the kinetic energy is half mv1 square and the gravitational potential energy is mgh. And if you simplify it, we will get v0 square minus 2gh equal to v1 square. So the left hand side is matching what we see in the options, but the right hand side is not in v1, it is in gr. So if we find out what is v1 in terms of g and r, the gravity and the radius of the turn, then we can figure out which option is correct. So go to the second key point, the next key point, which is the key point, the force required at the highest point for the turn is provided only by the weight. So let us look at point y, right, and analyze what is happening. So the force, there is normal force by the ground because you have weight mg acting downward, right? Normal force is perpendicular to the slope, the angle is 90 degree. And we know because the person is making a turn, you will have centripetal acceleration AC. And the formula for that AC, the formula is AC equal to V1 square by R. V1 is the speed at the highest point, right? So AC, and that force is provided by the weight component, right? So we will write that G sine 30, right? That component is your AC, and that will be V1 square by R. And from here, you will see from here, V1 square is GR by 2. So that means option A is correct and option B is incorrect, right? Because V0 square minus 2GH equal to V1 square we found out before, and now V1 square is GR by 2. Now, let us look at option C and D. Now, they are about centripetal force at points X and Z, right? So let us look at this half circle, right? When you are moving on a circle, you need centripetal force, centripetal acceleration, and the force is mv square by r, right? And that is always acting towards A, always acting towards the center, right? Now, m is constant, r is constant, but v will be lowest at v is lowest, right? The you are slowest at y and v is max at x or z. And how do you know that? You can tell it by energy conservation, right? So for example, look at energy conservation between lowest point x and highest point y. At x, let's say you have a speed v2. So kinetic energy is half mv2 square. At highest point y, the kinetic energy is half mv1 square. And the gravitational potential energy, the difference between point x and y, will be mg r sine 30, right? So because the speed is highest at point x and z on this half circle, so the centripetal force will be maximum at point x and z. So option D is correct and option C is incorrect.